Assalamualaikum and greeting everyone, especially to my panel as Dr. Muhammad Farid bin Ismail and Dr. Ahmad Fuad bin Abdul Rashid. My name is Muhammad Amir Irfan bin Muhammad Shukri. I'm from Bmmu Station 1/2. I am supervised by S. Dr. Muhammad Haidir bin Maslan. Today, I would like to present my Bachelor Degree Project 1 with the title Design and Development of Water Quality Monitoring for Shrimp Tank. Before that, I would like to thank the panel and my supervisor who allow me to present this research. For my presentation outline, I will cover 6 main points, which is introduction, problem statement, objective and scope, teacher review, methodology, and expected result. So, for introduction, we start with question, what is water quality monitoring? Water quality monitoring is the process of regularly checking and evaluating the condition of water to determine if it is clean and safe for various uses. Furthermore, water quality monitoring for aquaculture farming is the process of assessing and maintaining the condition of water in shrimp farming system. It involves regularly testing and analyzing the water parameters that directly impact the health and well-being of aquatic organisms. In aquaculture, water quality monitoring focuses on factors such as temperature, dissolved oxygen, pH, ammonia, and turbidity. These parameters play a crucial role in the growth, reproduction, and overall health of shrimp. By monitoring these factors, farmers can ensure optimal conditions for their aquatic livestock and identify any potential issue or imbalance that may affect their growth or survival. For the next slide is, why is it important for water quality monitoring? Yes, first is optimal health. Monitoring water quality ensures the well-being of aquatic organisms. By regularly checking parameters like temperature, oxygen, pH, and ammonia, farmers can maintain optimal conditions for the growth and health for the shrimp. Second is disease prevention. Poor water quality can make aquatic organisms more susceptible to disease. Monitoring helps detect potential stressors and allow farmers to take timely action to prevent outbreaks, reducing the need for treatment and promoting sustainable farming environment. Third is improve productivity. Maintaining optimal water quality conditions directly impact the growth and productivity of aquaculture species. Monitoring parameters like dissolved oxygen and nutrient level enables farmers to create ideal conditions for faster growth and better feed conversion rate. Okay, for the next slide is who is responsible for water quality monitoring of shrimp tank. The responsibility for water quality of shrimp tank lies with the shrimp farmer or aquaculture facility managers. They are accountable for ensuring the optimal condition necessary for the health and growth of the shrimp. This involves regularly monitoring and assessing the key water quality parameters such as temperature, pH, dissolved oxygen, turbidity, and ammonia. Farmers may employ aquaculture specialties or use automated monitoring systems to gather real-time data. By taking proactive measures to monitor water quality, farmers can ensure the well-being of the shrimp and the success of their aquaculture operation. Okay, for the last slide for introduction is, when is good time to take a data for water quality of shrimp tank? So the best time to take the data for water quality in shrimp tank is during routine monitoring interval or at specific interval throughout the day. Is it recommended to take the measurement at consistent and predetermined time to establish a reliable baseline for comparison? Some common time points for data collection include daily monitoring, before feeding, after feeding, during water exchange, during critical event. By following a consistent schedule for data collection, we can track change in water quality parameter over time, identify trends, and make informed decisions regarding the management of their shrimp tanks. So, we enter the section for slide, problem statement. First is challenge in shrimp farming. Shrimp farming face challenge related to water quality management and the precise control of multiple parameters for optimal shrimp growth. Shrimp require specific water quality condition and inadequate management can lead to suboptimal condition, increased susceptibility to disease, and significant losses. The second point is limitation of manual monitoring. Manual monitoring processes are labor-intensive, lack of real-time feedback, and can result in inconsistent and inaccuracy in data collection. Manual monitoring methods are time-consuming, prone to errors, and do not provide immediate information for timely intervention. The point is aquaculture result documentation can be troublesome by doing it manually. There is a need for an affordable, reliable, and user-friendly automated system that can continuously monitor and provide real-time update on crucial water parameters for shrimp farming. An automated system will address the limitation of manual monitoring and provide accurate, timely information and optimize water quality condition. Okay, for the next slide is about research objective and scope of research. So we see the research objective. First is to analyze the data collected from the sensor and make informed decision on the management of the shrimp tank, such as adjusting the water temperature, pH, and others. Second is to optimize the design of the water quality monitoring system. Third is design, develop, an automated water quality monitoring system by utilizing Arduino. Next, we see the scope of research. First is identification of water quality parameters such as pH, ammonia, turbidity, mix of oxygen, and temperature. They are critical for the growth and health of shrimp in aquaculture. Second scope is system development and programming coding using Arduino 1.8, 1.16 software. Third is evaluation of the performance of the developed water quality monitoring system in terms of accuracy, reliability, and cost effectiveness. And lastly, for the scope of research is integration of various sensors with the Arduino board to collect the data on the water quality parameters such as pH, temperature, turbidity, mix of oxygen, and ammonia sensor. So right now we go through slide literature review. We start with type of shrimp. So shrimp, a small but significant creatures in the aquatic world, belong to the Dicopada order and play a vital role in global aquaculture, including Malaysia. Figure in this slide show, according to Tightwell and Allen 2001, this type of shrimp found in Malaysia that are ideal to aquaculture, their attribute and why they are well suited for shrimp farming. Malaysia's tropical climate provide optimal conditions for shrimp farming. 3 species are predominantly farmed in the region. Is 1, the giant tiger shrimp. Second is white leg shrimp. Third is banana shrimp. According to Leung and Engel 2020, these species are preferable due to their fast growth rate and high demand in the market. With careful planning and management, these species can support a thriving aquaculture industry in Malaysia, contribute significantly to the country economy and food security. As you can see, this is the previous project that I found in the journal for my research, the literature review. So the first project I found is the system they use wireless sensor network and single chip computer network. The microcontroller is they use CC2520 module and network ZigBee communication global system for mobile GSM. Second project I found is wireless mesh sensor network. They use the controller is Librium WASP mode, and the network they use is mesh networking transceiver. And last project that I found in the previous journal is GPRS communication system. The controller they use 16-bit microprocessor MSP 430F149, and the network they use is GPRS. So as you can see, this slide about type of shrimp tank. The design of shrimp tank is fundamental in the successful cultivation of shrimp. Several considerations need to be taken into account, including tank size, shape, and material. The tank size should provide sufficient space for shrimp to move and grow without overcrowding, while the tank shape should facilitate efficient water circulation. According to Sukumaran 2017, circular or oval-shaped tanks are commonly used as they promote better water flow and prevent stagnant areas where water quality can deteriorate. As you can see, the figure in this slide show concrete tanks, eaten pond, recirculating aquaculture system tank, and acid tank. This slide tell about shrimp tank farming process. The vital period to monitor the water parameters is post-larva period in the nursery pond and farming pond, which is most of the time it will spend 4 until 6 months before harvesting process as figures show. These 2 ponds need to be monitored as maintaining good water quality is essential for shrimp growth and health. So right now, we enter the section about methodology. As you can see, this is the research flowchart. So we start with literature review. Then from my research literature review, I get idea for doing concept design development. After that, I split it into 2 parts for hardware, software, integration and programming. Next part is microcontroller. I determine on the microcontroller after analyzing the component and the appropriate programming language to use for the microcontroller. And after settle the microcontroller, so I make the product assembly. After done the product assembly, next part is testing and commissioning. So if the testing is failed, so that will return to product assembly. And if the testing done smoothly, that will return to result and data verification. After that, we make the discussion and conclusion. That's all for research flowchart. Next part, talk about block diagram and concept circuit design. So for the block diagram, as you can see, the first is shrimp tank. This is central component representing the tank or enclosure where the shrimp are housed. It serves as the environment that requires constant monitoring of water quality parameters. Second is power supply. The power supply is responsible for providing the necessary electrical power to operate the entire system. It ensures the continuous functioning of all components, including sensor, microcontroller, display unit, alert system, and data logging, to maintain uninterrupted monitoring of the water quality in the shrimp tank. That is sensor. These are the essential devices that measure various water quality parameters such as temperature, pH, piece of oxygen, ammonia, and turbidity. The sensors are placed in the shrimp tank and collect real-time data regarding the water condition. And next part is microcontroller Arduino Uno. It receives the data from the sensor and process it to determine the current water quality status. So, after settle the microcontroller, we go through the display unit. The display unit provides a user-friendly interface to present the real-time reading of water quality parameters. And the same part for display unit is alert system. Alert system is an important component that monitors the collected data for any deviation from the desired range or predefined threshold. If any water quality parameters exceed the acceptable limit, the alert system triggers all visual indicators to notify the user of potential issue. So the next is data logging. The data logging component store and record collected data over time. It enables the storage of historical data which can be used for analysis, trend identification, and decision making. By logging data, long-term pattern and trend in water quality can be identified, helping in the assessment and optimization of shrimp tank condition. The next part is connectivity. The connectivity component offers optional integration with external device or networks. It allows for remote monitoring and control of the water quality in the shrimp tank. This feature provides convenience and flexibility to the user, enabling them to access the real-time data, receive notification, and make adjustment or intervention remotely. And lastly is system housing. The system housing is a protective enclosure that houses all the components of the water quality monitoring system. It ensures the physical protection of the component from water, dust, and environmental factors. The system housing also helps in organizing the component, reducing the risk of damage, and maintaining the integrity and reliability of the system. So you can see behind the block diagram is concept design circuit. In the design circuit that I made, they have component OLED display, temperature sensor, ammonia sensor, DO sensor, turbidity sensor, and pH sensor. So this is my concept circuit design that I made for water quality monitoring shrimp tank. So for the last slide for methodology is about model design sketching. This design sketching figure show how the system proposed fully works. The system consists of sensor, microcontroller, display module, and other components working together to provide real-time data and facilitate necessary action. At the core of the system are the sensors, strategically placed within the shrimp tank. The sensors include pH sensor, temperature sensor, ammonia sensor, turbidity sensor, and dissolved oxygen sensor. Each sensor is responsible for monitoring a specific water quality parameter critical to the well-being of the shrimp. The collected data from the sensor is then transmitted to the controller, such as Arduino, which acts as the central processing unit of the system. The microcontroller receives the sensor data and perform necessary calculation or adjustment based on predefined threshold or user-defined parameters. To provide immediate feedback and visualization, the microcontroller communicates with a display module. This display module can be a LCD screen or OLED display. The real-time data is presented in a user-friendly format, allowing shrimp tank owner or aquarists to easily monitor the water quality parameters at a glance. For comprehensive data analysis and historical data tracking, the system can incorporate data logging capabilities. This can be achieved using a SD card module or by sending the data to cloud server. Data logging allows shrimp tank owner to analyze trends, identify patterns, and make informed decisions about tank maintenance and water management. So next slide is about expected result. The result aim to demonstrate the system effectiveness in collecting accurate and real-time data on crucial water quality parameters. The expected result serves as a foundation for further analysis and discussion, paving the way for potential. As you can see, I made the programming, and the programming consists of constant definition, function declaration, sensor reading function, a data logging function, and a threshold checking function. The code is written in C++ and follow a modular approach to achieve the desired functionality. So this is my expected result. The expected result will be the data, the sensor will monitor data continuously, and data from the sensor export to the Arduino. The Arduino will be sent to the system or displayed the data in the LED display. So for the last slide is about Gantt chart. For the last slide for today is about the Gantt chart. So this is my Gantt chart for Bachelor Degree Project 1 and Bachelor Degree Project 2. So for my Bachelor Degree Project 1, I start with project registration, collect and analysis of information, and I made the Chapter 1, Chapter 2, Chapter 3. After that, submit first draft and turn it in. And then submit compile logbook. After settle the checking first draft. And then I made the report correction. After settle the report correction, I submit final draft PSM report for my supervisor and also for my panel. And then right now I made the PSM 1 video presentation and I will submit after that. Furthermore, as you can see, for my Bachelor Degree Project 2, I start with hardware integration, software development, product testing. After settle the product testing, so I can start the Chapter 4 about result and discussion. And from the product testing, we'll put the result and discuss about the sensor and everything. And then Chapter 5, lastly, project presentation and full report submission for Bachelor Degree Project 2. That's all from me. Thank you for your time to watch my video presentation. Thank you so much. Assalamualaikum.